Hi everyone, this lesson is for Algebra 2 honor students. This is day 7 of chapter 5 on quadratics. So today we are covering sections 5.5, which is evaluating quadratic functions with f of x values, and as well as section 5.6, which is finding the equation of a quadratic given 3 points. So we're going to get started with warm-up, and for the warm-up we are given a quadratic equation, and our job is to find this in vertex form. So we're going to do that right now. Vertex form is we're going to use completing the square. So we're going to move this 2 over to the left first. That's our first step. So we're going to say y plus 2 is equal to x squared plus 3x. Now, this is in the right form. We have 1 for our x squared term, which is exactly what we want. We're going to take half of 3, which is 3 halves, and then square that, which is 9 over 4. We are going to add 9/4 to both sides because that is an equation. On the left, we are going to simplify by multiplying by 4 over 4 to get common denominators. So that's going to be 9 plus 8. So 9 plus 8 is 17 over 4 is equal to, I'm going to factor this right side, which is x. Both are plus, and then square root of that is going to be 3 over 2, quantity squared. So my answer is going to be, invert my vertex form is going to, the quadratic equation is going to be y equals the quantity x plus 3 over 2 quantity squared, and then minus 17/4. This is what's called vertex form. And then you also need to find the vertex from the vertex form, which is negative 3 over 2 comma negative 17/4. And so once you have this, then you also have the axis of symmetry, which is the line that goes right through the vertex that makes both sides of the quadratic symmetric. And so that equation is a line. So you're going to start off saying, well, that's going to be x equals, and then it's this value right here, which is negative 3 over 2. Now, just to note that if I hadn't completed the square to find that and I was asked to give the axis of symmetry, I could have just said it's x equals negative b over 2a, and that's the actual formula for that. So let's graph this. So we have negative 1.5 and then down, 4 1/4 or so. There's the vertex. We know that the y-intercept is negative 2. It's going to come up like this. And then to the left, also being symmetric, we have our axis of symmetry that goes right through here. And yeah, so the only other information that would be, what you would want to know is like the domain. The domain goes from negative infinity to positive infinity. The range goes low to high. So the lowest value here, which is this value. So you would say the range is going to be from negative 17/4 all the way up to infinity. And then additionally, we would want the x-intercept. So I would use, let's see, that doesn't factor. So we're going to use the quadratic formula. So we would say x is equal to set y equal to 0, back up here in the original equation. The opposite of b, so negative 3 plus or minus the square root of b squared, 9, minus 4 times a times c, all over 2a, 2 times 1. So we have x equals, and then let's work this out. Negative 3 plus or minus, let's see, 4 times 1 is 4 times 2 is 8. These are two negatives and it makes plus, so that's 8. 9 plus 8 is 17. This is all over 2. So, and that's, that's the square root of that. And so these are, those are solution sets. Those are my x-intercepts. I would expect that you would be able to tell me also the answers as a decimal. And so note to self, I did put 2 different quadratic formulas, programs for you, one for the TI Inspire and one for the TI 84 on the slate. So you should be able to program your calculator to do that super quickly. And you can check your answers. So we're going to do this on here. So we're going to start off with negative 3. Maybe. So negative 3 plus square root of 17. So that's going to go like this. Square root 17. And I'm going to put a decimal there just to give this a like an approximation. And so enter, that's going to give me this value, but that's not my answer because I still have to take that value, the -3 plus that value, and I need to divide that by 2. So I'm going to go divided by 2, and then I'm going to equals. And so one of my answers is going to be 0.561 or 0.562. And then the other value will be -3. And this one will be minus. So we're going to go minus the square root. So square root of 17. I'm going to put another decimal there. And I'm going to go enter. And for this one, now I still have to divide by 2. So divided by 2. And I get that value, which is negative 3.6. So going back to our work, my two values, where's my pen? My two values are going to be here. It would be, let's see here, we've got negative 3.6, and also we have 0.562. Okay, so those, and basically what you could see there's your 0.562 right there, your x-intercepts, and then here is about, negative 3.6 or so. Okay, so our learning targets for today are basically to, given a quadratic equation, be able to calculate the y and the x for an unknown. Also, you're going to be given 3 points, and you're able to come up with the quadratic equation. And for that, you are going to be using, matrices, and that's going to be the quickest way to do it. So we're going to start off with this. The first one is just a composite, which we've had a lot of practice with. We're given f of x quadratic equation 3x squared plus 2x minus 11. You have to find these three things. So the first thing you're going to do is you're going to plug in -4. So you're going to say, well, f of -4 is equal to 3 times -4 quantity squared plus 2 times -4 and then minus 11. And so for this problem here, I honestly, I would just plug this in my calculator. We've got 16 times 3, which is 48, and then we've got minus 8, which is now 40. 40 minus 11 is 29. So this value for this first problem is just 29. Now the second part of this problem is they're saying find x. Now they're giving me this equation, this equation right here. Now this is saying f of x, which is y, is equal to -6. So this right here is what they're replacing. So instead of plugging in -6 for x, you're not doing that. You're saying y is equal to -6. So they want you to plug in -6 here. And so they're saying, well, if that's -6, then you have 3x squared plus 2x minus 11. And now in order for me to solve for x, which is saying, hey, find the roots or the intercepts, I need to move this over and set this equal to 0. So we have 3x squared plus 2x, and then to get this over to the other side, I'm going to add 6. So that's minus 5. Now, possibly a factors, possibly not. I'm just going to use the quadratic formula, and I'm going to say x equals the opposite of b, so -2 plus or minus b squared, which is 4, minus 4 times a times c, all over 2a, 2 times 3. And so what that does for me is, what, 12 times 5, oh, that's 60, right? And then 4 minus 60 is negative 56. That's imaginary. Okay, so here we go. 4 minus 60 is negative 56, and this is all over 6, and this equals x. I'm not going to leave that answer like that because right here, what I'm looking for is, number one, this is, you've got a negative sign, and that means under the root, that means that that's I. Let's see. Additionally, I know that 56 can be divided by, I think, 4, right? At least I know 56 divided by 4 is 14. 56 also can be divided by 8. All right, right, yeah. So what we're going to do is this. We're going to go x equals -2 plus or minus, and then I'm going to take this negative sign out first. So now I have I. And then 56, that's the negative sign. 56 actually is 8 times 7. And so I know that 8 isn't a perfect square, so you really can't factor that out. So we're just going to take 4 And so that's going to be 4 times 14. So that right there is going to be square root of 4, which is 2, and then leaving the square root of 14 under the root. So what we have is 2, and then don't forget the I, square root 14, and this is all over 6. And just keep in mind that if you have all of these are even numbers, or all of these are factors where you can divide out at 2 or something, some common multiple, then what you would do is you would, one way to do that is to split it like this, 2 over 6, plus or minus 2I root 14, also over 6. So both of those are going to cancel and make 3. So that's going to be negative 3 plus or minus, oops, I'm sorry. Let me fix that. 1/3, by the way. That's going to be negative 1/3 plus or minus I root 14 also over 3. And put this in solution sets because that's the way you would definitely write that answer. All right. The last part of the problem is basically them saying, we want you to find the x-intercepts. Now, that's from the original equation, which is right here. And so just to find those x-intercepts, all I have to do is set that equal to 0. So I get 3x squared plus 2x and then minus 11. And yeah, you can complete the square and then square root both sides to find the answer. I'm just going to use the quadratic formula again. We go x equals the opposite of b plus or minus b squared. So that's 4 minus 4 times a, which is 3, times c, which is negative 11. And that's all over 2a. A is 3. And so here we go. So we go x equals negative 2 plus or minus the square root of. And so what I have here is a positive number. It looks like I've got 11 times 4, which is 44. And 44 times 3 is, oh, that's 132, which is 12 times 11. So anyway, that's 132. And then plus 4, which is 136. And so that's all over 6. Now, 136 will cancel. It is not a perfect square, so that's not going to cancel into a perfect square, but let's see what that will give me. About 11. So anyway, using the TI Inspire, that's going to actually reduce that for you. So I'm going to look at that really quick, and I'm going to go to my TI Inspire, and I'm going to say, hey, I want to take the square root of 136 and get an answer. 2 root 34. There you go. Okay. Oh, let's go back. Oh. And so we've got negative 2 plus or minus 2 root 34 all over 6. And also that can be reduced with the 6's. So you again have negative 1 plus or minus the square root of 34 all over 3. And this you would put in solution sets equal to x. And that's when you have 0. And then this is when f of x is equal to 6, negative 6. So this one is saying another equation, 2x minus 11, same equation actually. And what they're saying is, for this problem, if there are real values of x, then y does reach the given value. If the values are complex or they don't reach that, then y does not reach the given value. So use the discriminant, and what they're asking you to do is say, well, does f of x ever equal negative 5? So if I plug in this for negative 5, and I go negative 5 is equal to 3x squared plus 2x minus 11. Set equal to 0. So I go 3x squared plus 2x. And what I'm doing is adding 5 to both sides, and I get minus 6. Now, if I use my discriminant and I say b squared, right? The discriminant being b squared minus 4ac. 4 minus 4 times 3 times negative 6. So this is a positive number because this is a negative times negative is positive plus 54 or plus 4. And so that's positive. And what that means is because that is positive, then there are real values. And so that's what that's asking you. So at the very top, it says, does this ever reach this? Yes. For this one, yes. Because there's real values because it's positive. For negative 15, we would plug in negative 15 equals 3x squared plus 2x minus 11, set it equal to 0. So we have 3x squared plus 2x, and then add 15 to both sides, right? So adding 15 to both sides is going to give me 4 plus 4. And so b squared, which is going to be 2 squared, which is 4 minus 4 times a, which is 3, times c, which is 4. You're looking at this and you're saying, well, this is 4 minus 48, right? Which is 12 times 4, which is 48. That's going to yield a negative value. And since the discriminant is negative, then the solutions to this equation will not be real. So therefore, f of x never reaches negative 15. Well, as the other one, because it was positive, it did reach negative 5. So that's how you do that. This problem here, it's saying find the values for which this is happening with this quadratic. You have y is equal to 3. So they want the values of x. So again, ideally, what they're looking for are the roots again, but you have to set it equal to 0. And what's happening is because each one of these values has a different value, you have to set it equal to 0 if it's not actually in a 0 initially. So here we go. We have 3 equals x squared plus 8x, and then add 15. So if I subtract 3 from both sides, because I want to move this over to set this equal to 0, I get x squared plus 8x plus 12. And 12 does factor to be 1 times 12, 2 times 6, and then 3 times 4. And I do know that 6 and 2 is going to add up to 8. So this is going to factor. So we're going to factor this one. We're going to say that this is x plus 6 times the quantity x plus 2. And then both of these values, since that's equal to 0, I can set these both equal to 0. X plus 2 equals 0. So we know x equals negative 2. And then we know x is equal to negative 6. So my solutions for the first problem are going to be negative 6 and negative 2. And just a note, like if you wanted to graph that, right, negative 2 is here, negative 6 is here. They didn't ask us for the vertex, but I do know that 15 is like, let's say, up there, which means that if I wanted to, say, sketch this, it might look something like that, okay? Now for this problem here, this one is saying y is equal to 0. So we have 0 equals x squared plus 8x, add 15. And again, for this problem, this does factor pretty nicely. And so we have x here, we have plus 3, and, plus 3 and plus 5, because 5 times 3 is 15, adds up to 8. And then we're going to split this up, and we're going to set both sides equal to 0. So we have x is equal to negative 3, and we have x equals negative 5. So my solutions are going to be negative 5, comma, negative 3. And then, again, if I wanted to sketch that, I know negative 5 is here, negative 3 is here. I know my y-intercept is 15 again, way up here. So it's slightly different than the other one, but equally, you do have a minimum on both of the equations. This is another one, just if you wanted more practice on the initial part of the assignment. So this is saying plug in negative 3. So you would get negative 4 times negative 3 quantity squared plus 4 times negative 3, add 15. And so we get 9 times negative 4, so that's negative 36, minus 12, and then add 15. So I'm just going to do that. I get negative 36 minus 12, and then add 15. What is that? 33, negative 33. So f of negative 3 is negative 33, and that's it. Just box that up. For this one, I'm actually finding the x-intercept, so I do set this equal to 0, and I get negative 4x squared plus 4x, add 15. And so right here, I'm going to, when I set this equal to 0, I can use the quadratic formula. I'm wondering, I'm going to try completing the square to just see if that gives me a different outcome. So I'm going to subtract the 15 onto the other side, so I get negative 15 is equal to negative 4 times the quantity x squared minus x. And then I'm going to take half of 1, which is a half, square that, which is 1/4. But when I add, what I add to the other side is negative 4 times 1/4, so that's negative 1. And so on the right side, I get negative 4 times x minus 1/2 quantity squared. On the left, I get negative 16. So now I'm going to square root both sides, but before I do that, I see this negative 4. I'm going to divide by negative 4 on both sides. So that's going to get rid of this, and it's going to reduce this. So if I divide both sides by negative 4 like this, and this is attached, so you don't put a negative 4 under the x minus 1/2 either. These are going to cancel. I end up getting x minus 1/2 quantity squared is equal to positive 4. And so now when I square root both sides, on the right, I get x minus 1/2. And then on the left, I get plus or minus 2. And I'm going to move this over to the other side. And so I get x equals 1/2 plus 2. And I get 1/2 minus 2. And those are my two. That's my plus or minus. So this answer is going to be 2.5. And then the other answer is going to be 1/2 minus 2, which is equal to negative 1.5. And so my two solutions for this are x equals, so you'd write x equals and put this in solution sets, negative 1.5 and then 2.5. And not parentheses, but solution sets. And for this last problem here, this is saying f of x, which is y, is equal to 20. And so I'm going to plug that in. I'm going to get 20 is equal to negative 4x squared plus 4x, add 15. So I'm going to subtract 20. 0 equals negative 4x squared plus 4x. And then if I subtract 20 from both sides, right, I get negative 5. And again, I'm going to use the quadratic formula. But I could also complete the square like I did in this part on the right to do that. I'm not going to do that. So we're going to go, I'm going to go x equals the opposite of b, negative 4, plus or minus b squared. So that's going to be 16 minus 4 times negative 4 times negative 5 all over 2a, which is that. And so I've got 4 times 4, which is 16. And 16 times 5, that's 80. But these three negatives make negative 80. Negative 80. So what that means is I've got 16 minus 80, which is negative 64. So my value underneath the root is negative 4 plus or minus negative 64 all over negative 8. And so what that's going to do here is 64 is a perfect square, but it's negative. So that means that I'm going to have two imaginary solutions. So we're going to go x equals negative 4 plus or minus, and this value, it's like this. That's so annoying. Square root of negative 1 times the square root of 64. So that's going to be 8i. So plus or minus 8i, and this is over negative 8, and this is over negative 8. See this negative 8 on the denominator? And so what that's going to give me is x equals 4 over 8, which is 1/2. X equals 1/2 plus or minus negative I. And then that's it. And so that's going to be my solution when f of x, or y, is equal to 20. So again, this part here, we already did a value like this. This is saying use the discriminant to tell whether or not the indicated function is ever has a given value. Like I said, all you have to do is plug these values in here. 2x squared plus 3x plus 6 and set this equal to 0. 2x squared plus 3x. I'm going to subtract 1 from both sides, and I get plus 5. And then I'm going to use the quadratic, or excuse me, I'm going to use the discriminant, which is b squared minus 4ac. So 9 minus 4 times a, which is 2, times c, which is 5. So 8 times 5 is 40. So this is saying 9 minus 40. 9 minus 40 is a negative value. And so that's negative 31. And what that tells me is that because this is negative, therefore, because my discriminant is negative, then the value, or my quadratic will never reach 1. It'll never reach 1, y equals 1. It'll never reach that because this is imaginary, so it'll never do that. So what I've shown you here is, I know we've talked about the complex plane a couple of times, and we've talked about just, having a parabola that's sort of floating, right? But what this is doing here is this is my floating parabola right here. But what I wanted to do is I wanted to show you what this actually looks like, something like this. These are given these points 3 plus 5i and 3 minus 5i. This is what, like, on its imaginary plane that you can't see on this complex plane with the imaginary numbers and the real numbers. This is what, like, you can't see. But this is what it looks like if you could see it in another dimension on a complex plane. Okay. All right, so this is a review problem, very important problem. I already told you many, many times. You are to find the particular equation of a quadratic function given the vertex and a point that it's containing. So let's just graph that just for really quick. This is 2, -5. That's my vertex. It contains the point 3, 1, that point right there. So it contains that point. So what it's saying is that my graph, my parabola, 2, -5, is going, kind of looks like it's going up, doesn't it? Like that. And so therefore it must go up on this side like that. Well, that's pretty cool and all that. And I know my axis of symmetry is x equals 2, but they're not asking me that. What they want to know is this. They want to know, given the vertex and a point, come up with the actual equation. So coming up with this equation, we're going to start with vertex form, which is y equals a times x minus h quantity squared plus k. Okay? That's where h comma k is the vertex. That's what that is. All right? And that's my axis of symmetry. So we're going to plug in our vertex, hk. And if you notice that h is the opposite. So if it's hk, right? You should know that this value is going to be, the h value is going to be the opposite. So here we go. Y equals a times x minus 2 quantity squared, and then plus k. K is -5. All right, so now, given this information, I have 3 unknowns, 3 variables. So, I mean, I can't come up with an equation with 1 equation and 3 unknowns. I'd need 3 equations for that, right? So hold that thought. We'll come back to that. We are given the point 3, 1. And so this is x and this is y. So plug that in here. So we've got 1 is equal to a times x, which is 3, minus 2, quantity squared, and then subtract 5. So 3 minus 2 is 1. 1 squared is 1. So I have 1a. Minus 5 is equal to 1. Add 5. I get a is equal to 6. Because realistically, a was the only value that I didn't know in this equation, right? This is the vertex form of the equation. A is the only value that I don't know. So in order to find that, I did need another point to plug in. So now that I know what a is, I can say, therefore, my quadratic equation in vertex form is y equals 6 times the quantity x minus 2, quantity squared, add 5. And so this is my equation in vertex form. Hold on. That's not right. That should be a minus 5. Thank you. There we go. Minus 5. I was looking at this plus, but it's actually plus negative, which is minus. Okay. Now the second new thing that we're doing today is we are trying to find an equation of a quadratic given any 3 points. So like just any 3 points, but however, we are not given the vertex. We have other 3 points. We have 3 other points, okay? And so a couple of things that you need to remember, and one of those is this, that you need to always start with this equation that looks like the standard form. So y equals ax squared plus bx plus c. So that's what you're going to do. You're going to remember that form, all right? And so I'm going to start off actually graphing these 3 points, okay? So the 3 points I've got -2, -11. I've got 4 and 13 way up here, and then I've got 6 and then 29 way up there. I have no idea what that looks like since I didn't graph it completely accurate. So without knowing what those points look like, I guess I could use Desmos. So I did use Desmos. I just paused the screen for just a minute and I plotted these points on Desmos, and it sure looks like the graph is coming up on this like this. It looks like it's going like this. And I mean, I don't know that this isn't the vertex, but I'm assuming it's not. So what we're going to do is this. This is how you figure this out, okay? So we're going to actually shrink this a little bit and get this out of the way so that we can try to figure out what these values are, okay? So, all right, the way you do this is you start off with this equation, which is your quadratic equation. And what you're given are these 3 points. You're given this is x, this is y. That's x, that's y. That's x, that's y. And you're going to plug in each one of these points into this quadratic equation, or the standard form for the quadratic, equation. So we're going to plug the first point in, which is -2, -11. So y is -11. So we're going to go -11 is equal to a. We don't know a, but we know x. X is going to be -2 quantity squared plus, we're still on this point. We're on this point right here. Plus b times x. X is again -2, and then plus c. C, we don't know c, we don't know b, and we don't know a. But we do know x and y. So if I was, let's say, rewriting this, right? If I was rewriting this into a different, just be a little bit more clear, right? This would be 4a minus 2b plus c is equal to -11. And then for the second point, right, this point right here, I'll use green for this one, we've got 13 is equal to a times 4 squared plus b times 4 plus c. And rewriting this equation right here, just simplifying it, would be 16a plus 4b plus c is equal to 13. And then for the last one, the 629, we would get 29 is equal to a times 6 squared plus b times 6 plus c. And then that would give me a simplified version. Oops, let me use the same color, blue. And so that would give me 36a plus 6b plus c is equal to 29. And what you now have, right, is this equation. And these three, you have 3 equations, right? And you have 3 unknowns. And that makes a 3 by 3, which we've done multiple times and tested on it. And at this point, we are not testing you on that anymore. So we do expect you to, if you have a calculator, use it. And so what that means is that I'm going to plug these values into my calculator. So plugging the values into your calculator, whether you have the TI-84 or the TI Inspire, the TI-84, remember, you're looking for the A, typing your values into a 3 by 3A, and then you hit inverse, and then your values B. But before you go A inverse B, you have to type in a 3 by 3 and then a 3 by 1 for A and for B. And then you plug, and then you type in A inverse B. Whereas for the TI Inspire, you just plug the values in as is. So we're going to go to a 3 by 3, 3 by 3, and then we're going to type the values in. We have the first value is 4. Then we have a -2. And this value is a 1. This value is 16. Then we have 4, and then we have 1 again. We have 36. This value is 6, and then this value is 1. To the right, you're going to make that in inverse. So you hit that little hat button like that, and you go -1. Arrow, use the arrow over, okay? And then the arrow over, you're going to make it a 3 by 1. Now, on the TI Inspire, it doesn't have a 3 by 1, so you're going to take this 3 by 3 and make it into a 3 by 1 by changing the column value number to 1. Hit OK, and then our value is going to be -11, so -11, and then you've got 13, and then down here I have 29, and then you hit over, and then you hit enter, and then it looks like I get 1/2, 3, and then -7. Let me write that down. 1/2, 3, and -7. And so what that's going to do for me is, because those are my A, B, and C values. So when I do a 3 by 3, right, I have A is equal to 1/2, B is equal to 3, and C is equal to -7. So what that means is my quadratic equation now is going to be, let's see, it's going to be this value here. You're going to plug the values in. So you're going to go 1/2 x squared plus 3x minus 7, and this equals y. And so this is my equation for my quadratic. Right on. Okay, let's do this one more time and practice. So again, we're going to take the y equals ax squared plus bx plus c. We're going to plug these numbers into this equation. And, you know, there are multiple ways to solve a 3 by 3. You could use a calculator. Also, you know, you could use a like substitute elimination, or you could use the Kramer's rule, right, with the multiplying. Whatever works best for you. I'm going to start. We're going to say the first value, this is x, this is y. So we get 5 is equal to a times x, which is 0 squared plus b times 0. Plus b times 0, and then plus c. And then the second one is going to be 13 equals a times 2 quantity squared plus b times 2, and then plus c. And then the last one is 26 equals a times the quantity 3 squared plus b times 3, add c. So rewriting these three equations, okay, that's what I'm going to do. I actually get 0, 0, I get 0, 0, c, 0 plus c, which is equal to 5. So I already know that c equals 5. Like, this value is 5. We already know that. And which means that when I plug 5 into the other equations, I might decide to solve by elimination, because that might be quicker than plugging all the values in. I don't know. Here we go. Then this is going to be 4a plus 2b. Okie dokie. 4a plus 2b plus c is equal to 13. And then we have 9a plus 3b plus c equals 26. So I'm going to plug my values in. I already know what c equals, but I'm going to do this again on my calculator. I'm going to clear the calculator and go to new. So for this problem right here, we are going to start off with y equals ax squared plus bx plus c. We're going to plug these values in and into this equation. And remember, this is x and this is y. So we're going to go 5 is y. 5 equals a times x, which is 0 squared, plus b times 0 plus c. And then you're going to have 13 equals a times 2 quantity squared plus b times 2 plus c. And then you're going to have 26 equals to a times 3 squared plus b times 3 plus c. So rewriting this, we're going to get no a, so that's just no a value plus no b value plus c equals 5. We get 4a plus 2b plus c is equal to 13. And you get 9a plus 3b plus c equals 26. And so I'm now going to plug these values into my calculator, and now I'm going to use the TI-84. And so using the TI-84, the way you do that, let me get to quit. So you quit everything. You go second matrix, and I'm going to go over to edit, but my A value, I'm going to make my A value a 3 by 3 because I have some other work that I was doing there. So I'm going to go enter. This is going to be a 3, enter, 3, enter. And so those values are going to be 0. Oh, man. Those values are going to be 0, enter, okay, so 0, enter. Okay, see if I can get that to work. 0, enter, 0, enter. And then this last value, C value, which is 1, that's going to go enter. Then the next row is going to go 4, 2, 1. And then the last row will be 9, 3, and 1. Okay, and then you go second quit, and then you go second matrix, and you go over to edit. Now, I know I put my values on A, so I'm going to scroll down to 2, and I'm going to enter that, and I want that to be a 3 by 1. And making that a 3 by 1, those values will be 5, 1, 3, and 26. Okay, so let's see if this works. We go second quit, so then we go second matrix, hit A. If you don't do anything, you don't go over to edit, you just hit enter, and you should get an A. And then you're going to hit inverse right there, and then you go to second matrix, and you roll down to B, and you hit enter. So that's A inverse B, which is the same thing we were doing with the TI Inspire, but you just typed it in a little bit differently. You hit enter. My 3 values are 3, -2, and 5. And those values are actually your A, B, and C. So therefore, we're going to go therefore, if my values for A are 3, B is equal to -2, and we already knew C equals 5, right? Because C equals 5. We're going to put this value, because the whole point of this is to find the quadratic equation. So you're going to go y equals 3x squared minus 2x plus 5. And therefore, there's my quadratic equation that contains those 3 points. So tonight's homework, you've got the 5.5 and 5.6 homework. And thanks so much for watching, and I hope this helps you.